About 30 years ago, there was no scientific proof of a planet outside our solar system. Due to technological and scientific advances, we've discovered over 5,300 exoplanets, alien worlds waiting to be explored. Our capabilities have allowed us to discover smaller, Earth-like exoplanets. Initially, we found large gas giants. Over 50 exoplanets with Earth-like masses and 800 with radii less than 1.5 times Earth's have been discovered by scientists. We know a few planets and their parent stars' habitable zones, where life can thrive. Change is already underway. We're finding planetary systems with multiple potentially habitable planets as we search for them. We know of at least one such system in our cosmic neighborhood. Numerous compact systems in our Milky Way galaxy revolve around sun-like stars. However, planets orbiting these stars are usually too hot for life. However, the habitable zone around colder, fainter stars is closer. This is Gliese 667, GJ 667, a triple star system in Scorpius 23 light-years from Earth. It contains the first known example of a low-mass star with multiple potentially habitable rocky planets in its Goldilocks zone. The system has 3 stars like Alpha Centauri. The largest K-type main sequence star in the system is GJ 667a. This orange-red dwarf has 73% mass, 76% radius, and 12% visual luminosity for the Sun. GJ 667b, its companion, is a K-type orange-red dwarf at $12.50 and radiates 5% of our star's visual luminosity. Its mass is 69% of the Sun's. Like Alpha Centauri, the third star is most intriguing. Gliese 667c is a M-type red dwarf with 33% of the Sun's mass and 34% of its radius. Its luminosity is 1.4% x-Sun and its surface temperature is 3,775 Kelvin, compared to 5,772 Kelvin for the Sun. Despite its small size, GJ 667c has a rich planetary system. Researchers initially thought there were only 3 exoplanets orbiting Gliese 667c, but after reviewing data and making more observations, they found 6. With 3 or 4 being exoplanets. What is a super-Earth? The term refers to a planet larger than Earth but smaller than Jupiter and Saturn. These rock or rock and ice planets may have atmospheres that support life. Hot planet Gliese 667cb is the closest to the star at 200 degrees Celsius, 392 degrees Fahrenheit. The most massive exoplanet in the system, about 5.5 times Earth's mass, orbits its host star in 7 days and likely has a thick atmosphere. The 3 potentially habitable planets in the Gliese 667 system are farther from their host star and have masses between 1 and 5 times Earth's. Next closest planet Gliese 667cc orbits the star's habitable zone's inner edge. Its year lasts 28 Earth days and has a mass of 3.8 and a radius of 1.8 times Earth. The Holy Grail of extrasolar planets, it has an Earth similarity index of 0.85. Given its low energy output, the red dwarf GJ 667c's habitable zone is close to the star, from 11 cents to 0.23 Australian dollars and entirely within Mercury's orbit. To compare, Earth is $1 Australian from the Sun. Our planet would be ice if it orbited star C at that distance. The red dwarf GJ 667cc orbits its parent star 8 times closer at 12 cents every 28 days. Due to its proximity, the exoplanet may be tidally locked to the star, with eternal day and night on opposite sides. Drastic temperature differences between the 2 sides may affect the exoplanet's global climate. Gliese 667cc receives 10% less solar light than Earth. Since most of its light is infrared, the planet receives about the same amount of solar energy as Earth, which would help retain water on its surface and create a similar climate. The surface temperature of Gliese 667c cannot be predicted because scientists don't know if the planet has an atmosphere or how thick it is. If the planet has an Earth-like atmosphere, it would transfer heat and equalize temperatures, making the night side 30 degrees Celsius, 86 degrees Fahrenheit. living on such a planet would be different. The star gives GJ667cc a faint reddish glow. Gliese 667a and b, the other two stars, are 230 Australian dollars away from Pluto and the Sun and outside the planetary system. However, the two other suns would appear as bright stars during the day and as bright as the full moon at night. Our Sun would appear as a distant star. Unfortunately, the nearby red dwarf emits flares and energetic particles up to 1,000 times stronger than those on our Sun. This could be problematic for any life on Gliese 667cc, which is near its flaring host star. The red dwarf's strong magnetism may cause star spots that reduce its energy output by 40% for months, which, along with the lack of ultraviolet light emissions, could hinder life's formation. Because Gliese 667cc is so big, living there would be different. The exoplanet's higher mass causes a different surface gravitational acceleration. This rocky world has 60% higher gravitational acceleration than Earth. A 75 kilograms, 165 pounds person on Earth would weigh 120 kilograms, 265 pounds, on Gliese 667cc. Additionally, a planet with a higher mass can hold a more massive atmosphere, increasing surface atmospheric pressure. If the exoplanet has a Venus-like atmosphere, its atmospheric pressure could be several hundred times higher, equivalent to Earth's ocean's water pressure several kilometers deep. Despite being in a habitable zone, Gliese 667cc may not be like Earth. Gliese 667cc life may have to adapt to low light, high atmospheric pressure, and frequent flares. However, life can form on such a world. Life on Earth has shown remarkable adaptability. The other two habitable planets are similar. Gliese 667c and CF receive less energy because they are farther from their parent star. This could make them too cold for life. However, unlike GJ667cc, a thick atmosphere would trap heat and maintain favorable temperatures, making these planets suitable for life. 3 such planets in the habitable zone of the same planetary system are rare, but 4 is nearly impossible. One study found that 5 planets in the Gliese 667c system receive 20 to 200% of Earth's solar radiation, making them potential habitable. There are other factors. Scientists found 2 habitable zones around Gliese 667c for a planet with Earth mass. The inner boundary is 0.095 to 0.126 AU from the star, and the outer boundary is 0.241 to 0.251 AU. Life may be possible on any planet orbiting star C at these distances because it has the right conditions for liquid water. The heat from a planet too close to its star will evaporate water, making it uninhabitable. Water vapor, a greenhouse gas, traps heat and raises temperatures to intolerable levels. Only planets at the inner edge of the habitable zone with a higher mass resist the moist greenhouse effect. However, like the outermost Gliese 667g, a planet too far from its star risks ice. CO2 can warm the planet and prevent this, but too much can cool it by reflecting light. So CO2 can only warm the planet so much. Astronomers announced in 2013 that Gliese 667c has at least 6 planets, and may have a 7th, GJ667ch. The controversial exoplanet may be the smallest found around star C, with a mass of at least 1.1 times Earth's and located between C and B. Planet H is too hot for life to form due to its mass and proximity to the parent star, 0.0893 Australian dollars. But F and E are confirmed to orbit in the habitable zone. Planet D's orbit is uncertain, but its estimated location is outside the habitable zone. This implies that Gliese 667cc, CF, C, and possibly CD are habitable. The discovery of densely packed planetary systems around M-dwarf stars like Gliese 667c suggests that many planetary systems with several potentially habitable planets exist. Since M-dwarfs make up over 70% of all stars in our cosmic neighborhood, our galaxy may have many more promising planetary systems than previously thought. Scientists can now search one star for multiple Earth 2.0 candidates instead of 10 stars. Thanks